Assalamualaikum and a very good morning to everyone. Today, we from Group 6 will present about mathematics in Islamic civilization. And this is my group members. First, let's take a look on Islamic mathematician. Our first Islamic mathematician is Muhammad ibn Musa al-Khawarizmi, also known as father of algebra. He was a mathematician and also an astronomer. He had a strong advocacy of Hindu numerical system, which is 1 to 9 and zeros. He pioneered study of algebra, which we can see in his book Hisab al-Jab wal Muqabalah, which also known as al-Jab and in English is algebra. He also introduced the fundamental algebraic method, reducing and balancing, and also solving polynomial equation. He also developed systematically solving quadratic equation. He also credited with the development of lattice or sieve multiplication method of multiplying large number, a method algorithmically equivalent to a long multiplication. Our second Islamic mathematician is Omar Khayyam. He generalized Indian method of extracting square and cube root to include fourth, fifth, and higher roots. He carried out systematic analysis of cubic problem. He offered geometric solution of cubic equation and partial geometric solution of the other equation. Our third Islamic mathematician is Muhammad al-Karaji, also known as Abu Bakr ibn Hussein. His work covered arithmetic, algebra, and geometry. He introduced the theory of algebraic calculus. He used method of proof by mathematical induction to prove his infinite sequence statement and binomial theorem. Our fourth Islamic mathematician is Ibn Yusuf Yaqub ibn Ishaq al-Hindi. He wrote 4 volumes of number system in Kitab fi Istimal al-Hadad al-Hindi. He laid the foundation of a large part of modern arithmetic. Our fifth Islamic mathematician is Nasir al-Din al-Tusi. He was an astronomer, scientist, and a mathematician. He theorized on the quadrilateral and he made enormous advances in plane and spherical trigonometry. His major mathematical contribution was the formulation of the famous law of sine, which is A over sine A equal B over sine B equal C over sine C.
Islamic numeral. The Islamic Empire established across the Persian, the Middle East, Central Asia, North America, Libya, and part of India. From the 8th century onward, made significant contribution through mathematics. One consequences of the Islamic prohibition on depicting the human from was the extensive use of complex geometry pattern to declare their buildings, risings, mathematics to form of an art. Okay, next number 0 to 10, call it Hindu Arabic numerals. Origin in India in the 6th century or 7th, using Eastern Arabic number 0 to 10 were introduced to Europe through the writing Al-Khawarizmi and Al-Kindi. Okay, next development of Hindu Arabic numerals. Indian 1st century after the AD, it's called. Okay, you can see 1st century, 9th century, 11 in India, and East Arab 11th century, West Arab 11th century, 15th century, and 16th. Okay, Islamic computational arithmetic, decimal system and arithmetic system. Okay, so you can see at the screen, The decimal system, just like that. Okay, the arithmetic system, you multiply the 2 decimal place and 1 decimal place, it become 3 decimal place. Okay, next. The number from 1 to 9 represent by 9 digit, all easily made by 1 or 2 stroke. The rightmost digit of numeral counts the number of units, and a units in any place is the of that is right. Right that. Okay, decimal arithmetics. Decimal arithmetic introduced to Arab number into Europe. It have two part. Involve more than a way of writing down. Involve new way of calculation with pen and paper. If or lattice method for long multiplication. The lattice method is an alternative to long multiplication for numbers. In this approach, a lattice is first constructed such to fit the numbers begin multiply. If we are multiplying an m digits numbers by an n digit numbers, the size of lattice is m multiplied by n. The multiplicate is placed along the top of the lattice so that each digit is the header for one column of the cells. The multiplier is placed along the right side of the lattice so that each digit is a header for each row of cell. Illustrated above is the lattice configuration for computing 948 multiplied by 827. Step 1 for lattice method. Draw a grid and divide each box with a diagonal line. The number of row and column will depends on the number of digit in the factor. Step 2. Arrange the factor along top and right side of the grid. Step 3. Multiply the number that each is spaced on the grid. 10 and 1s are split by the diagonal line each space. Step 4. Continue to multiply until all of the space on the grid have been filled. And the final step, step 5. Add the numbers in each diagonal row. Write the sum along the left side and bottom. These numbers become the final product. And there is another example as you see at the screen.
Islamic algebra. We all know father of algebra is Al-Khwarizmi. He named Abdul Jafar Muhammad Ibn Musa Al-Khwarizmi. He lived in Baghdad around 718 to 815 century. He was one of the first to write about algebra using words, not letters. Al-Khwarizmi helped establish widespread use of Hindu Arabic number such as 1, 2, 3, which replaced Roman numerals. Al-Khwarizmi algebra. The algebra represented in the book Hisab al-Jab wa al-Muqabala used words for variables, so it was not as convenient as the algebra we use today. Al-Jab means completion and al-Muqabala means balancing. His aim was to solve linear or quadratic equation by removing negatives using a process of balancing both sides of an equation. This is the same as what we do in algebra today. From Al-Khwarizmi name came the word algorithm. Al-Khwarizmi also present the procedures for solving 6 types of equations. The first one is squares equal roots, and the second, square equal numbers, third, roots equal number, the next, squares and roots equal number, number 5, square and number equal to roots, and finally, roots and numbers equal square. I give one example. To solve the equation ax power of 2 equal to bx, such as ax power of 2 plus 10x equal to 39, by Al-Khwarizmi's completing square methods. First, start with a square of side x, which therefore represented x power of 2. Add to this 10x by adding rectangles of length x and width 10 over 4. Each smaller rectangle has an area 10x over 4, or we can call 5x over 2, total 10x. We know this has a total area of 39. After that, complete the square by adding 4 little square with side 5 over 2, area of each 25 over 4. That means we got 39 plus 25 equal to 64. The sides of the outside square are therefore 8. But each side is of length 8 plus 5 over 2 plus 5 over 2. So x plus 5 equal to 8. Giving the answer x equal to 3. This is also another example.
Now we talk about Islamic geometry. Before we proceed with Islamic geometry, we must learn about geometry first. So, what is geometry? Geometry is the study of measurement and comparison of lines, angle points, planes, and surfaces. A shape is the outer form of an object or figures as a triangle, square, rectangle, and circles. There are 4 bases of geometry, which is 3-point geometry, 4-point geometry, 5-point geometry, and 6-point geometry. Now, we talk about Islamic geometry. In Islamic culture, geometry can be found in mosques, madrasas, palaces, and private homes. This tradition began in 8th century during the early history of Islam. The geometric design in Islamic art are often built on combinations of repeated squares and circles, which may be overlapped and interlaced to form intricate and complex patterns, including a wide variety of tessellations. This geometry design shows that the belief, which is our infinite. The geometric pattern occurs on variety of forms in Islamic art and architecture, including carpets, ceramic, woodwork, metalwork, and stained glass. Now, we learn about Islamic trigonometry. In early 8th century, Muhammad ibn Musa al-Khwarizmi created sine and cosine table. He also created the first table of tangents and was the first developed spherical trigonometry. Abu al-Wafa al-Buzjani, the Muslim mathematician, using all 6 trigonometric functions. He also developed trigonometric formula. For example, sin 2x equal 2 sin x cos x. Another example, cos 2x equal 1 minus 2 sin power of 2x. Habas al-Hasi al-Marwazi. Habas al-Hasi al-Marwazi established the first table of cotangents. Abu Rayhan al-Biruni. Abu Rayhan al-Biruni introduced triangulation techniques, which is the first developed by Muslims to measure the size of Earth and the distance between various places. He discovered mathematical formulas for finding exactly when seasons start and end. These triangulation techniques enable to determine the direction of the Qibla from anywhere in the world.
That's all from us. Thank you for watching, and remember, stay at home.